Okay, we're going to look at solving quadratics using tables. When we're solving quadratics, we want to look for two things. We want to look for where the vertex is, and we're going to look for where the solutions are, or the roots, or the zeros. So for part A, it says, tell which interval a solution to the equation f of x equals 0 is found, or tell if it is a double or imaginary solution. If it is a double, give its solution. Okay, so we want to find where the solutions are, and it tells us right here that that's when f of x is equal to 0. So we're going to look at this first table. So number 1, if we're looking at this table, we can see where f of x is equal to 0 by looking at these f of x values. Okay, so we have 38.5, 22.5, 10.5, 2.5, then it drops down to a negative 1.5. So you can see that the 0 is going to be right in between the positive 2.5 and negative 1.5, because that's where a 0 would be. That's where f of x would be equal to 0, would be in between those 2 points. Okay, so it's anywhere that you see a sign change on the f of x. Okay, so then we have a negative 1.5, then we go positive 2.5 again. So we have our second 0 right in between there. So the second f of x equals 0 is in between those 2 points. Okay, so how are we going to write that? Well, it's a between statement, so we're going to say, okay, it's where x is between negative 1 and 0. So let's write that. So between negative 1 and 0. And then also in between positive 1 and 2. So when x is between positive 1 and 2, we have another solution. Okay. So, all right, let's move on to part B. So it says, tell in which interval the vertex is found. Okay, so how are we going to find the vertex? Well, let's think of what the graph looks like. So I'm going to go ahead and draw a little graph right here. So if I'm going to do a graph, then I've got my points. I've got negative 4, 38.5. So that's going to be way up here somewhere. Negative 3, 22.5 is going to be coming down. And then negative 2, 10.5 coming down. Negative 1, 2.5, it's a little bit lower. We cross the x-axis, and now at 0, it's at negative 1.5. At 1, it's at negative 1.5, so those should be level, but they don't look very level. Then we have 1, 1.5, so that's coming back up. So you can see that the parabola is going to come down and then go back up. So where would the vertex be? Well, in between negative 1.5, or in between 0 and 1, sorry, the y value is at negative 1.5. So it's going to have to, the vertex is going to have to be in between those 2 points. So we're going to say the vertex is going to be right here. We've narrowed it down, and it's got to be somewhere in between those 2 points. So we're going to say that the vertex is when x is between 0 and 1. That's when the vertex is, where the vertex is. Part C says, is the vertex a maximum or a minimum? Well, what do you think? If the vertex is down here, is that a maximum point or a minimum point? Well, it's not a trick question. It is a minimum point because it's at the very bottom. So we're going to say it's minimum. Okay, so I want you to work number 2 and number 3. So pause the video right now and work number 2 and number 3. Okay, so now that you've paused the video and you worked 2 and 3, I hope you can check your answers here. Make sure that you got these answers right. I would just want you to remember that the 0 is going to be where the signs change from negative to positive or positive to negative. And then also remember that the vertex is where it starts to change direction. So in number 3, you can see it's going up, 11, 16, 17, but then it starts coming back down to 14. So you know that the vertex has to be somewhere in there. Okay, so let's look at number 4 and number 5 now. Okay, so now we're going to look at number 4. Number 4 is a little bit different. Let's look and see. If you look at your f of x values right here, you can see that they are all positive numbers. Now, it's asking, part A says, where's the 0? Well, this one's pretty obvious because, look, it has a 0. It has where f of x equals 0 is right here when x is 5. Okay, and then you can see that on either side of that, that's going to start coming back up again. So it also looks like that is your vertex, because on either side of this point, you have repeating values. So you have 1, 1, then you have 4, 4, you have 9, 9. So it's going to be symmetrical on either side of this point. So the interval, well, the interval is where x is equal to 5. It's not really an interval because we can see that that is our exact 0. Okay, and since it's coming down, it's hitting the vertex. So let me just draw a little picture up here. It's coming down, or yeah, it's coming down because it's up at 25. It's coming down, and then it's hitting the vertex, and then coming, I'm sorry, not the vertex, hitting the x-axis and then coming back up. So that means that that is what we call a double root. So it's a double root at 5 because it's coming down and it's hitting the x-axis and then it's turning back around. Okay, the vertex. Okay, so the vertex is the exact same point. The vertex is 5, 0. Okay, and is the vertex a maximum or a minimum? Well, you can see that it starts out at 25, and then it starts coming down, 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 and then goes back up. So you can see that it's going to open up, which makes that vertex right here, that makes that a minimum. Okay, let's look at number 5. Alright, so on number 5, we have f of x. If you look at your f of x, it goes from 27 to 15, 7, 3, 3, and then it comes back up. So 3, 3, 3, and then 7, 15, and then we can see that it's starting to get symmetrical again. Right, we've got 7, 7, 15, 15, 27, 27. Okay, so we can kind of sketch what the picture is going to look like. At negative 3, it's at positive 27, then 15, then 7, then at 3, and it stays at 3, and then it comes back up. So that the vertex is going to be in between those two 3s right here, but you can see that it's not going to touch the x-axis. There's not going to be a 0. So this is called, this happens whenever we have imaginary solutions, because you can't see them on the real number graph. So the zeros or the solutions or the roots are going to be imaginary solutions. And if you remember, we also call those complex solutions. Okay, so where's the vertex? Well, we said that the vertex is between when the f of x is at 3, so it's right in between here. That's where the vertex is going to be. So let's write that as a between statement. It's going to be when x is between 0 and 1. Okay, and then now we just need to answer, is it a maximum or a minimum? Well, you can see that right here, it's going to be a minimum point. Okay, so that's how we can use tables to solve quadratics.